My name is Svetlana Rubina. This is Neta bar. Let me present our project named Questions and Answers Based Summary Quality Prediction. So our way data mentor who helped us is Dina Bavli, and our AI21 industry partners are Yoni Osin and Yoel Zeldes. AI21 Labs is a company that provided us with the problem, with the data set, and it's an artificial intelligence research and development company that focuses on developing advanced natural language processing technologies and language models. One of their products is WordTune Read. It's an AI reader, and one of its goals is to summarize long documents so you can understand more information in less amount of time. WordTune Read generates summaries. In general, a generative summary is generated by a machine learning model that was trained to generate coherent and contextually relevant text. Now we're closer to our goals. Our goal is to continue, right? To evaluate generative summaries. Okay, so our goal is evaluation of generative summaries. It's a crucial but challenging task. It aims to assess coherence, readability, and relevance, and to measure the performance of different generative models. So there are different evaluation methods that include automatic metrics like Rouge and Blue, and also human annotation. However, existing automatic metrics rely on reference summaries and can't evaluate newly generated text. So now we are closer to our problem. The business problem was to evaluate summaries generated by AI21 Labs models. There are several use cases for this problem. The first one is best model choice. For example, when we have several models that generate summaries and we need to understand what model to choose, first of all, we need to rank and evaluate the summaries that they generate. The second is best summary choice. For example, when we have one model that generates several summaries and we need to rank them and to choose the best one or several best ones to give it to the customer. And also it's data curation. So our machine learning solution of this business problem is using the approach named question generation, question answer similarity to evaluate coverage and content accuracy of the summaries. And our project goal was to build a summary quality predictor using questions and answers evaluation approach with an accuracy better than random. So what is random accuracy? As we had 4 classes in our dataset, our random accuracy was 0.25, and in case of 2 classes, so we have good summary or bad summary, the random accuracy is 50%. So what is good and bad summary? There are several features of a good summary. First of all, it's coverage of main points, and also maintaining fluency and coherence, and sticking with the messages expressed in the original. And we had a data set that was labeled from 1, a good summary that reflects all the sense of the text, to very bad summary which contains some misleading information, for example. And okay and bad summaries are some way between it. So in general, we had a data set with 2,000 number of samples. The data set was labeled. We had 4 classes, so we had 500 of samples per class. And the content of one sample was text, its summary TLDR, and its label by human annotator. So we provided some EDA. For example, we calculated mean text length, mean summary length, and noticed some things that, for example, there seems to be a slight correlation between text length and labels, where good summaries tend to be shorter than very bad summaries. And according to mean summary length, we noticed that label 3 exhibits significantly shorter average summary length compared to the other labels, and we supposed that it influenced our results. So here we can see one of the examples. of text and the summary. So we can see in the text it's highlighted the main points. And the summary is that Instagram and Facebook users see curated content which can make them happy or inspired and depressed when their own lives are not perfect. It was labeled with 4, despite the summary quote the main meaning of the text. So people see the curated content and they either feel happy or they feel depressed. Why could possibly this summary was labeled with 4? Maybe because in the summary it's not written what content exactly do people see, and it's highlighted in bold in the text. So like it's great jobs, excellent partners, or beautiful homes. It's one of the possibilities. Another possibility that in the summary there is written that people feel happy or inspired and depressed. Really it's or depressed. We understand, a human can catch and understand their meaning, but probably the human annotator decided that it's incoherent information because of and instead of or. So as we can see, labeling data is a challenging task even for humans. For example, in case of 2 classes dataset, the level of agreement between human annotators were estimated as 70%, comparing to the random 50%. And in case of 4 classes, it could be even lower. So, Neta.
Thank you. Okay. So, as Sveta mentioned, the goal of our project is to evaluate the quality of a given summary using this question and answering approach. This approach actually measures the information overlap between a summary and a text, and it's supposed to reflect both the coverage and the accuracy of the summary. It includes 3 steps. So given a text and a summary, the first step is to generate relevant questions, for instance, based on the original text. The second step is to answer those questions based on the text and the summary. And finally, the third step is to compare the 2 answers and calculate a similarity score. This approach assumes that there is a correlation between the number of similar answers and the quality of the summary. Okay. So for these 3 steps in our question answering approach, we actually used 3 different open source pre-trained NLP models. For the first step of question generation, we used the T5 base model that was fine-tuned on squad dataset. It was trained to generate a question given a text and an answer. So in order to use this model, we actually used another NLP model by Spicy to extract non-chunks, and we use those as answers. For the second step of question answering, we used a BERT large model that was also fine-tuned on squad dataset to extract answers given a text and a question. And for the third step of comparing between the 2 answers, we used a sentence transformer model that was trained for semantic embedding, and then we calculated a cosine similarity score for the 2 embedded answers. So as Sveta mentioned, a sample in our data set includes a text, a summary, and a label from 1 to 4 that correspond to this good to very bad quality prediction. In order to train our quality predictor, we first pass all our data set through this question and answering part of the pipeline that includes the 3 steps I just mentioned. This part of the pipeline results in a list of similarity scores per sample that represent the similarities between answers from the text and answers from the summary. We then use these similarity scores as features along with the labels to train classification models. We focus on 2 optional classification models. The first is a multi-class classification that aims to predict the quality of a summary out of the 4 original labels. And the second is a binary model that aims to predict if a summary is just good or bad. So the two end parts of this pipeline actually represent 2 optional classification models and outputs. So now that I briefly mentioned our approach, our pipeline, and the models we use, I want to share with you some of the steps we took along the way. So during our error analysis, we actually noticed that some of the generated questions are quite similar. So to improve the performance of our model, we eliminated features from similar questions. We also added some features to the similarity scores to highlight the differences between the different classes. We added the mean and standard deviation of the similarity scores per sample. We added a question count after we deleted some of the similar questions. We also added a ratio of the number of similarity scores above 0.5 divided to the number of questions, and a ratio of the shared name entities between the text and the summary. So in the table below, you can see an example of the features we use to train our classifiers. The numbered columns represent the similarity scores between 0 and 1, 0 being very different, 1 being exactly the same. The score column is our labels, and then we have mean similarity and so forth. During the course of our project, we tried and tested different approaches, models, and methods. As I mentioned in the question answering approach slide, we started by generating questions based on the original text that should reflect both the coverage and the accuracy of the summary. But we also tested the alternative approach of generating questions based on the summary that focus on the quality of the content. And we tried the combination of the two. We also tested different question answering models. Beside the BERT model I mentioned, we also tested a contextual answer API by AI21 Labs and a T5-based model that was trained for question answering. Finally, we compared between different classification models, with the top ranking, top performing being Random Forest and XGBoost, and we finally chose Random Forest as it performed the best with all our options. So here we can see a summary of our results based on these 3 different question answering approach, questions from the text, questions from the summary, and a combination of the 2, with different training and testing options to train our summary quality predictor using Random Forest. So as I mentioned, we focused on 2 optional classification models, a 4-label ranking model, and a good or bad binary model. For the ranking case, we trained and tested on samples divided to the 4 regional labels. And the best performing, you can see that in the upper row. I don't know if I can point. Yeah, there we go. And the best performing model in this case was actually based on questions from the summary. You can see here highlighted in pink with a test accuracy of 35%. For the binary case, we tried a few different training methods, including training on all the data divided to good or bad, where labels 1 and 2 are good and 3 and 4 are bad. Also testing on that division. But we also tried training on the 4 original labels, testing on good and bad. And finally, we tried training on samples from only label 1 and 4, the extreme labels, testing on all the data divided to good and bad. And you can see here, and the best performing model in this case was based on questions from the text and got a test accuracy of 67.5. So there's just a closer look at the best performing ranking model that was based on questions from the summary using Random Forest classifier. And we got, again, a test or a validation score of 35% compared to the 25% of random accuracy for 4 classes. You can see from the left, from the classification report and from the confusion matrix, that this model performed the best predicting label 1 with 59% precision, and it really struggled predicting label 3 with only 16% precision. And if you remember from our EDA slide, Sveta mentioned that label 3 had an enormously short summary that might affect our result. So here we have a closer look at our best performing binary model that was based on questions from the text, also using Random Forest. And just a reminder, it was trained on the extreme labels of 1 and 4 and tested on all the data. This model train or validation accuracy reached 67.5 compared to the 50% of random accuracy. And again, you can see the classification report and the confusion matrix, and that this model actually performed the same for both options, both classes. So to conclude the project, the goal of our project was to develop a summary quality predictor using this question answering approach and surpassing the random accuracy. Our best ranking model for the 4 labels reached an accuracy of 35% compared to the 25% of random accuracy. Our best binary model reached an accuracy of 67.5% compared to the 50% of random accuracy. And this result is pretty encouraging since, if you remember, the estimated agreement rate among human annotators is only about 70%. So we really got really close to that bar. So to summarize, our work directly addresses the challenge of evaluating text generated by large language models, in our case, a summary, and we feel it has the potential to make valuable contribution toward this critical area of research. Thank you very much.